I guess the reason that I was hoping that I might explain this a little bit better is that it would be easy for me to say, like, just do this, this, and this, but I'm not sure that that would be as widely applicable. As I guess the point is that this, dealing with data like this, I think is, has a little bit sort of broader use, maybe. Maybe not. But again, nothing over here has changed from what we were doing earlier. The only thing that we did was we grafted these planes so that now it's treating them as sort of individual items as opposed to lists. So that as a result, right, does it make sense up to this point what's happening or no? So I guess all that I can say is that at this point, when we look at the data in this format, we know that all of this stuff represents intersections on the ground floor, right? These zeros. These represent the first floor, the second floor, the third floor, and so on. But what's happening is, if we feed them into this planar surface alone, like in this format, it treats them all discretely, right? Because they're all these individual sort of leaves on this branch, right? As opposed to treating them as a list of data, which is really what we want so that we can get those holes.
So how did you get those holes?
So this is a component called the path mapper. So essentially what it does is it has, you sort of give it, I'll delete it. So it's called the path mapper, this one. So the first thing you do after you feed data into the path mapper is you right click and say create null mapping. So essentially what this is, so create null mapping. What it's doing is it's saying, take data that's in this sort of this address and output it at this address. So what null mapping is, it means don't make any changes, right? So right now, there's no difference between what's going in and what's coming out. What we need to do is we need to collapse all of these, all of the zeros together, all of the ones together, all of the twos together. So we can do that by essentially telling it to abandon this fourth parameter, this d, right? So that's all I did was I took the d out of there, and so now it sort of collapses them based on similarity of A, B, and C, and D is just thrown out. And that's how it sort of flattens those sub-branches into one sort of like super branch.
What was that fourth parameter?
The D?
Yeah.
The D represents, so these correspond to these sort of addresses, right? So A, B, C, D. So essentially what that command is telling you to do is just ignore or abandon all of the D data.
D data represents every intersection for the plane. That's what they're.
So right now, essentially A and B represent nothing. They're just sort of residual. C represents the plane, and D represents the volume, the B rep volume. Right? So what we want is we want this stuff grouped by plane. So the address component, that the part of the address that references the plane is the C component. And the only reason that we know that is because we know that we have 7 planes, and we can see that this goes up to 7. Well, it goes up to 6, but it starts at 0, so that's 7. All right, why don't you?
In a way, it's like you're flattening
Yes.
the tree or flattening part of the tree.
You're flattening part of the tree, basically. You're just not
like
flattening the
intersection
whole
1,
thing.
intersection 2, and then intersection 3, which are each branches of the tree, and then it puts them all into the same branch.
Right. So this represents, so the 2 represents intersections with the second plane. And then the 0, the 1, and the 2 represent that plane's intersection with the first, second, and third of the referenced B-reps, the referenced polysurfaces, right? Is that?
Because there's a component called flatten, right?
Right, so here's what
And
flatten
that
does.
would just give you one long list of all.
Exactly.
Yeah.
So this is what Duncan's talking about as flattened tree, which it's just going to put everything into one list, which that essentially puts us back to where we were when we did a cross-reference, which again, even, this might actually work in this very narrow scenario. I don't think that it would, but in general, you should avoid flattening trees because all of this like data structure that you've worked so hard to preserve is like gone. So, would you guys just like to ask me questions about Grasshopper?
What does the N represent to the right of that list?
The N
Yeah.
is the number of items in that list. Here. And so this is a little bit confusing. So in this list, most of them are ones. Where we have a 2, that's the result of no intersection. So when a plane doesn't intersect one of the, it's essentially just superfluous, like empty data. So this is saying that
Nice.
that first plane doesn't intersect one of those BREFs, basically, which is why we get the screwy data. So I guess, I don't know, I apologize that I couldn't make this a little bit more coherent. I know that I was kind of all over the place. But we can carry this out a lot further. I'm not sure, it doesn't seem like, I don't know if it's going to be that helpful. Which is not a criticism of y'all, it's really a criticism of me. But I can keep going. Madam President?
Sorry, go ahead.
No, just.
I was just gonna ask, so the little note bubbles, talk bubbles above every one of those. Click on it.
This?
Tells you why they're there.
Oh, just real quick interruption. Is that only part of the new Grasshopper? Because I never noticed that in the old Grasshopper.
I think from version 6 of 0.64, they have these trees. And it may actually be that you actually have to tell it to draw what it says, draw fancy wires, otherwise it just draws all the wires the same. I mean, you can get away with doing a fair amount of stuff without this, but if you when you really get into like complex stuff and you're referencing a lot of different things, you'll start to find that things aren't happening as you expect them to happen because of how Grasshopper is matching data. And so if you can really like force yourself to learn how Grasshopper deals with data and how it sort of what happens when you have these collisions of different sort of types and structures of data, then that really is the key to really understanding it. And I mean, I think that you can probably get about 25% of out of Grasshopper without understanding this to some level. But if you want to really, really, really get it, I think you have to understand this. And again, I'm sorry that I couldn't really make it a lot more clear. I'll actually post a couple of files that have a bunch of these steps sort of laid out to try to demonstrate each piece of this sort of like data structure puzzle. And so it may be more helpful if you could go through those sort of on your own to understand what's happening, maybe. So, Jesse, as far as these little error bubbles, the reason this has an error is because some of the planes don't intersect some of the VREFs, which that's all that it's telling you. Object contains, so the error is intersection failed, which is failing because it doesn't exist. This has an error because, and this has an error, this has an error because there's nothing feeding into here. So this error is input failed to collect data, which means you didn't give it anything. You didn't give it anything. It needs more data. So yeah, yellow is sort of like a warning. Red is an error. A lot of times, if you have a red bubble, everything after it won't work. The intersection commands are a little bit different because they sort of understand that everything isn't always going to intersect everything else, and so doesn't break the chain, so to speak. Yeah.
This is a little more confusing, but it seems like Grasshopper is one of those programs that there's at least get the same result.
Yeah.
So you find that there's like a method that you found that's doing something easier.
Just in general, stuff.
Is the graft, you know, there's probably a way to do it where you make the volumes and then do it? Is there, I don't know, how do you usually decide, do you have this something that you want to make and then, is there like?
I mean, I think that certainly for me, I generally use Grasshopper, especially recently, essentially as a tool. Just like I might use a straight edge to draw a straight line, I use Grasshopper to, if I need to draw 100 things that are all slightly different, right, I use it to do that. So in other words, I have sort of an expected outcome, and I'm always working towards that outcome. I guess I have also, like, especially in Chris Height's studio, we did a bunch of parametric design basically, and in that it wasn't as the outcome wasn't as expected. So in that case, it just becomes about sort of seeing what happens and reacting accordingly. And I think the biggest key is just to try to, as best you can before you start, think out what the steps are, and try to use that as a guide to sort of inform what you're doing. And even if you want to think about it in terms of how would I accomplish this in Rhino, what steps would I take in Rhino to do this, then you can follow that same logic in Grasshopper. So does that answer your question at all? I mean, I don't know how else to, like in this case, I don't know. I mean, I guess there probably is a different way to do this.
Well, you know, for instance, when we first started, you had all the data input, like a number of floors, so that
Right.
you started with that, and then you did then you like linked it to the thing. I mean,
Right.
it seems like you have a method of
Right.
going about doing this.
No, I mean, I think that really just relates back to what I was saying, which is, make sure you understand, make sure that you can sort of think through the parts that you need. I mean, I don't necessarily always lay out everything that I need beforehand, but I think that that's a helpful tool, especially if you're not comfortable with Grasshopper, is to really try to think it out beforehand and use Grasshopper in a very sort of predictable way. And I think once you learn how to use it like that, then you can start to use it when the outcome isn't as predictable. And oftentimes if I'm creating a solution that's a mile long, I'm going to realize throughout the process, okay, well actually I need to know this too, and so then that's another sort of parameter that I'm adding. I don't know how to answer the question any better than that.
What do you usually use Grasshopper for?
Again, I use it as a tool to do things. So I have one Grasshopper that I made that helps me do certain types of laser cutting. So if I have a solid, it'll slice all the sections and lay them onto a sheet that represents the laser bed and space them and all that sort of stuff. So that's something that I've worked on over a long period of time. It started off as something really simple, and it has kept getting more complex, but it saves me a lot of time. Recently I was designing this sort of sort of sinusoidal building that had a lot of apartments in it, so I used it to draw the apartments basically, based on sort of those curves so that each apartment has certain parameters in common, and then I didn't have to keep reorienting a bunch of stuff.